Imagine peering into the vast, inky blackness beyond the familiar orbit of Neptune, past the icy debris of the Kuiper Belt, even further than the most distant objects we've ever charted. What if, lurking in that profound darkness, is an unseen behemoth, a world so immense, its gravity silently sculpts the orbits of countless minor planets, pulling them into strange, synchronized dances we can barely comprehend. For decades, astronomers have whispered about a phantom planet, a hidden heavyweight, often called Planet Xa mythical ninth, or even 10th, world whose very existence challenges our understanding of our own celestial backyard. Is it just a theoretical construct, a figment of mathematical models? Or is there truly a colossal, icy giant, a ghost planet, patiently awaiting its grand reveal, a cosmic shepherd herding its flock from the cold, distant edges of our solar system? The evidence, it turns out, is becoming increasingly compelling. The story of Planet X isn't new. It's a celestial mystery with roots stretching back to the 19th century. After Uranus was discovered, astronomers noticed its orbit didn't quite match predictions. A gravitational tug-of-war was suspected, and brilliant minds like Urbain Le Verrier and John Couch Adams independently calculated the position of a new planet. And there it was, Neptune, precisely where the math said it should be. But even after Neptune's discovery in 1846, some residual anomalies in its own orbit, though much smaller, led to the hunt for new Planet X, a more distant perturbing body. This search eventually led to Clyde Tombaugh's discovery of Pluto in 1930. For decades, Pluto was hailed as Planet X, the ninth planet. However, as our understanding grew, we realized Pluto was far too small, a mere dwarf planet, utterly incapable of exerting the necessary gravitational influence. The original Planet X, the one meant to explain Neptune's wobble, was, in a sense, never found. Fast forward to the 21st century, and the concept of Planet X has been dramatically resurrected, not by subtle tugs on gas giants, but by the peculiar behaviors of tiny, distant ice worlds. Beyond Neptune lies the Kuiper Belt, a vast disk of icy objects, and further still, the even more sparsely populated region of the scattered disk. It's here, among the extreme trans-Neptunian objects, or ETNOs, that the true mystery unfolds. Scientists notice something bizarre. The orbits of several of these distant objects, worlds like Sedna and 2012 VP-113, are highly elongated and tilted, but critically, their perihelia, their closest points to the Sun, are all clustered together. Imagine throwing a handful of darts at a dartboard, but instead of landing randomly, they all consistently hit the same small area. Not only that, but their orbital planes, the angles at which they orbit the Sun, are also strangely aligned. This clustering, this strange cosmic choreography, is incredibly difficult to explain by chance. The probability of it happening randomly is minuscule, something like 0.007%. It strongly suggests the presence of a massive, unseen object, a gravitational puppet master, tugging these distant worlds into their unusual alignments. This is the modern Planet X, now often referred to as Planet 9. So what kind of planet could do this? Calculations by astronomers Konstantin Batygin and Mike Brown at Caltech suggest Planet 9 would be a super-Earth or mini-Neptune, roughly 5 to 10 times the mass of Earth. It would orbit our Sun at an astonishing distance, perhaps 400 to 800 times further out than Earth, taking anywhere from 10,000 to 20,000 years to complete a single revolution. At such a vast distance, the Sun would appear as merely another bright star in the sky, and its surface would be perpetually locked in an icy, twilight realm. The challenges of detecting such a world are immense. A planet of that size, so far away, would be incredibly faint. It reflects very little sunlight back towards us. Its own internal heat, if any, would be minimal and difficult to spot with current infrared telescopes against the background of cosmic dust and distant galaxies. It's like trying to find a single, unlit matchbox in a pitch-black football stadium from miles away, using only a tiny flashlight. Compounding the problem is the sheer amount of sky to search. The potential orbital path of Planet 9 covers a vast expanse, meaning astronomers need to systematically scan huge swathes of the cosmos for tiny, slow-moving pinpricks of light. Nevertheless, the search is very much on. Observatories worldwide, from the Subaru telescope in Hawaii to the Pan-SDARRS facility, are meticulously combing through sky surveys, looking for any object that moves at the precise, sluggish pace expected of Planet 9. Powerful telescopes like the Vera C. Rubin Observatory, once it comes online, will significantly boost our chances, capable of surveying the entire southern sky every few nights. While the evidence for Planet 9's gravitational influence is strong, some alternative, albeit less likely, theories have been proposed. Could it be that the clustering isn't due to a planet at all, but rather a primordial black hole, roughly the size of a grapefruit, with 5 to 10 times the mass of Earth? While intriguing, this idea faces its own observational hurdles, as detecting such a tiny, non-radiating black hole would be incredibly difficult. Others suggest it could be the cumulative gravitational effect of many smaller, undiscovered objects, or even a modification of gravity itself at these extreme distances. However, the simplest explanation, the one that fits the data most elegantly, remains a distant, unseen planet. The discovery of Planet 9 would be a monumental achievement, not just confirming the existence of a new planet in our solar system, but profoundly impacting our understanding of how our solar system formed and evolved. It might even offer clues about other planetary systems, suggesting that such distant, large planets might be common. It's a testament to the fact that even in our own cosmic backyard, mysteries still abound, waiting for us to uncover them. As our instruments push the boundaries of vision, we stand on the precipice of perhaps the greatest discovery in solar system astronomy since Pluto, potentially revealing that the universe we thought we knew was merely a whisper of the grand, unseen symphony playing just beyond our grasp.